Today we are going to learn how to name alcohols, a branch of hydrocarbons that include the hydroxyl group, which is an OH group. Any compound that contains carbon and hydrogen and an OH group is considered an alcohol. To name an alcohol, you include the root name as we have been doing, but this time you're going to change the suffix to include an -al instead of -ane. Now I like to remember this because an -al ends in -ol, and so does the word alcohol. When we name alcohols, our numbering rules change slightly. Instead of providing a lowest combination of numbers for side chains, we must always assign the hydroxy group the lowest possible number. In my first example here, the simplest of all alcohols, we don't need to worry about numbering because there is only one group of hydroxy groups off of the one carbon. To name, I will name exactly the same way we have been doing. My hydroxy group indicated means it's an alcohol, which means that I'm going to end in -anol. So I write -anol. I then indicate the longest continuous carbon chain for my backbone. In this case, it is a 1-carbon chain, and so therefore gets the root name meth. This is methanol. Note I did not write a number 1 since it is on the first carbon. Again, looking at something a little bit more complicated over here, I can identify the functional group, which is the hydroxy group. So what makes this compound different from our regular hydrocarbon? And note that this needs to be number 1, so it is attached to the first carbon. Please note that every time you see a vertex or the end of a line, a carbon is actually indicated. There is no carbon here though, as it is simply indicating a bond from the first carbon to the oxygen atom. Now, to name, we're again going to start with acknowledging the hydroxy group as being our alcohol, so it gets -anol at the end. We're going to acknowledge also the longest chain, so 1, 2, 3, 4, 5, so that is pent. And just like we have been doing, we will indicate side chains by using prefixes with the appropriate number. So a 1-carbon side chain is methyl. And we're going to number according to the hydroxyl group having the lowest possible number. So 1, 2, 3, 4, methyl. Pentanol is our final number. Again, please note the hydroxyl group must have the lowest number. Okay, again, we can use another example. It looks a little bit more complicated, but in fact, it is quite similar to what we've been doing already. Our numbering system will, to indicate the presence of the hydroxyl group, will change just a little bit. We again are going to make sure that our longest continuous carbon chain has the hydroxyl running off of it. So again, if you get confused, just put the C's in where they should be. And you might be tempted to put a C there, but it already has a chlorine. There's a C there. So our longest possible continuous chain is 1, 2, 3, 4, 5, 6. So it's going to have a hex. This time, however, our hydroxy group is not on the end. It's not on a terminus, a terminal carbon. So I'm going to go 1, 2, 3, or I can go from this side 1, 2, 3, 4. I will choose the lowest possible number, so I'm going to number in this direction. And this time I can add the ending -anol. So there's N. And this time I'm going to indicate what carbon the hydroxy group is on by putting a 3 in the middle of that suffix. So it's hexane 3-ol. Of course, I'm not quite done yet because I have my side chains that I have not yet looked at. This is going to be a chloro group. This is going to be a methyl group. And adhering to our rules regarding alphabetical order. I'm going to put the chloro first on 6. So 6 chloro dash. I'm now on 3 methyl hexane 3 all. Of course, we can draw these diagrams as well. When given a name, we're just simply going to dissect it, just like we did any other hydrocarbon. So again, looking at the root word oct here is going to tell me that I have 8 carbons, so I can draw that first. 4, 5, 6, 7, 8. Since I'm drawing, I get to choose which direction, so I'm just going to go 1 to 8 from left to right. And I know that the 4 here is indicating the OL, says that's a hydroxy group. So the 4, 1, 2, 3, 4, has a hydroxy group. And then I can start adding on my side chains as indicated. So chloral means Cl. It's on second, and there's 2 of them as indicated by the die. The methyl means a 1 carbon chain on carbon 5. 1, 2, 3, 4, 5. There's my methyl group. And I've done all the side chains, so I can go back and start putting in my hydrogens as we have been doing in practice. And there I have my diagram done. Again, we can also have cyclic alcohols. Again, decode the same way. Prop means 3 carbon. So 1, 2, 3, and I drew it in a circle as indicated by the prefix cyclo. It says propanol. Okay, so at the anol means that there's an OH group, and I simply put it on 1 OH. Then I can go around and fill in everything with hydrogens as you would normally. I like to note there is no number indicated because on cyclic molecules, our rules still apply. Must have the lowest number. So it would make no sense to start numbering over here 1, 2, 3. So on cyclic with a hydroxy group, there would be no need to have a number. That's a quick tutorial on how to name alcohol groups, and please complete the homework as instructed.